Hello everyone, my name is Aman Saini and I hope you all are having a great day. Today I will be discussing about portfolio optimization and analysis using Markowitz model and Theorem. Before I move to the actual model, let me introduce you to the portfolio and few advantages. So when it comes to the investment, portfolio is necessity because it provides streamlined process as well as the flexibility through diversification. And thus making a portfolio for the investment is the fundamental yet attention requiring task in investment. It can be made of various securities like assets and assets like stocks, future contracts, options, bonds, foreign currencies, as well as precious metals and goods. Now, as of any process, the optimization of a portfolio comprises three steps. The first is to analyze. Now in this step, investors should ask oneself about the personal needs and the goals, because one investment that works for one person might not be working for another person. The second step is that to get the information. Now it is very important when it comes to investment to be well informed, because it is necessary to have the information of the market fluctuations as well as the volatility to select the best possible stocks for the portfolio. Now once these two steps are done, we can move to the strategy and later buying of the stocks. For this study, I will be using Markowitz model, and after that I will generalize the results using Theorem. For this study, I will be using the data set which comprises 7 stocks. As you can see here is some information about the stocks as well. It has market capitalization, the dividend percentage, the annual revenue, as well as the expected rate of return. Here you can see the actual database for my study. The first column of each and every stock represents the daily high, and the second column represents the normalized data. Now the normalization is very important here because as you can see, the price of the stocks differs drastically, and to avoid the mistakes, the normalization is better before doing any before using any statistical method. Now moving on to Markowitz model. Here you can see the formulation of the model. The one half in the beginning is just for the sake of simplicity. The objective of the model is to minimize the risk which is present in the portfolio. The expression of the objective has the weight of the stocks as well as the relationship between the stocks. The sigma represents the covariance of the assets. The R dash represents the mean rate of the return of entire portfolio, as well as W represents the various weights of the certain stocks. The model also has assumptions as well as conditions. There are two assumptions. One is that the investment should be single period investment, and the second is that the investor is risk averse. The two conditions of the model is that the portfolio mean must be equal to the R dash, and the summation of all the weights must be equal to 1. Here you can see the spreadsheet containing the Markowitz model. This is the covariance matrix, which is like the major part of the model, as it represents the relationship between the stocks. This is the actual data set. Here you can see the weights of the stocks and the expected rate of return of each and every stocks. This two row represents the quadratic equations of the objective function, as well as you can see the constraints. Once this model is prepared in Excel, I use the GRG nonlinear algorithm to run the model. For this study, I ran the model for 2 cases and multiple times. The first case is that the portfolio is made of 5 stocks, and second is that it is made of 7 stocks. Now the interesting fact is that for this particular case, for this particular study, I got the exactly same results for both cases, and I will throw some light and explain it in the detail once we move to the conclusion part. Here you can see the feasible region as well as the efficiency frontier of the result. The orange curve represents the feasible region of the portfolio, which is of some stocks. Here you can see the 22%. If we set the portfolio rate of return equal to 22%, we will have the lowest risk. And as we move away from the 22%, the risk increases. Here, this orange curve represents the efficiency frontier, so it would be best to select the rate of return of the portfolio from any point on this efficiency frontier. The experiment supports the theory because you can see the result. The feasible region is bullet shaped, which is exactly same as the theory of the Markowitz model. Once the model is successfully run, I generalized the results using two-fund theorem. Here you can see the formulation of the two-fund theorem. The notations are all the same as of the Markowitz model. So the two-fund theorem states that any two efficient portfolios can be used to generate efficient portfolio each and every time. And for this study, I arbitrarily selected two portfolios with the rate of return equal to 14% as well as 16%. And again, I used the Excel solver as well as constraint satisfaction to generate this result. You can see the results over here in this yellow table. So this V1 and V2 are the two vectors which represents the weights that can be used to construct an efficient portfolio each and every time instead of running the model again and again. Now moving on to the conclusion. There were a lot of findings once my study was over, but I want to highlight two major findings here. The first case is of the Apple and the 32% rate of return of the portfolio. So as you can see, when I set the rate of return of the portfolio at 32%, Apple takes the major share in the portfolio at 84%. Now, this might be suitable for risk preferring investor, but I highly suggest that he or she should not be using in 32% of rate of return, because the reasons are that if you select the rate of return at 32%, it diminishes the very foundation of making a portfolio. The reason we are making a portfolio is to hedge against the risk of the market through diversification. Here you can see, if we select the 32%, and if Apple gets a hit, the whole portfolio would suffer. And thus investors should be aware and pay attention to the mixture of the portfolio before finalizing the rate of return. The second thing is that the Markowitz model is purely quantitative model, and thus it doesn't consider the quality of the stocks and the reputation of the market or sectors. For this reason, it gets very important to shortlist the stocks only after a thorough research. As I mentioned before, I obtained the same results for both 5 and 7 stocks portfolio, and that result was very interesting as well as eye-opening. The reason is that because the model is highly based on the fact that it addresses the relationship of different assets of the portfolio, as well as we get the chance to select the return of the portfolio. And as we go towards the higher rate of return, the model pushes the stocks with high expected rate of return into the portfolio, even though the risk would increase drastically as a result. So in a sense, this model doesn't just optimize for risk, but the constraint satisfaction also plays a major role within the model. And so the selection of the rate of return of the portfolio is one of the most important factor for the model to be dependable. And so once the packet of the stocks and the overall rate of the return are meticulously selected, the model becomes highly dependable for constructing a portfolio, given the fact that it is based on the relationship among the present stocks. And with that, it concludes my presentation. If you have any question, you can contact me through my email, which is displayed over here. And thank you very much and have a great day.